4.1 degrees, radians, and revolutions, video number 2. So we're going to pick up on this problem right here, where we're converting 3/4 pi into revolutions, and because there's 2 pi radians in one full revolution, we divide by 2 pi, just like we would have divided by 360 on the previous page to figure out the number of revolutions. Here, because we're working in radians, we divide by 2 pi. And when you're dividing, we get 3/4 pi times, when you divide by a number, you multiply by its reciprocal. Well, we have a pi in the numerator and a pi in the denominator, so the pi's cancel. And with fractions, you multiply across the top. And we get 3. On the bottom, we get 8. So we get 3/8 of a revolution. 7.4. Some of you might be thinking, well, did you forget to write the pi? I didn't actually. In A and B, I had the pi there, meaning these are exact answers. I didn't multiply the pi out. I could have said 2 times pi, and instead I could have called this 6.28, but instead I left pi in the answer and called it 2 pi. 3/4 pi, if I had wanted to, I could have multiplied it out, and when I multiply 3/4 times pi, I would have gotten approximately 2.356. 7.4 just means the pi has already been multiplied out. So we can simply take 7.4 and divide by 2 pi, because that's how 2 pi radians are what is in one complete revolution. So on my calculator, I'm going to take 7.4 and I'm going to divide by 2 pi. Now be very careful when you do this division that you put the 2 pi in parentheses. Otherwise, your calculator will divide by 2 and then multiply by pi. And I get 1.17746,579, if I want to be exact. So it's about 1.18 revolutions. Now, once again, I could go to my calculator and see what type of a fraction that is. All right, so I'm going to show you how I did that on the calculator. The 7.4 divided by, now I need to make sure that I put 2 pi in parentheses. Otherwise, I would end up dividing by 2 and multiplying by pi. And I'll see what that would be as a fraction. Math. Enter, enter. And it doesn't convert it to a fraction. So I'm just going to have to give an estimate here. And I'll say that's approximately 1.18 revolutions. Right, for 13 pi, I would take 13 pi divided by 2 pi. And I realize that the pi's cancel, and 13 divided by 2 is 6.5 revolutions. Now, because all of these are positive, I'm going to assume that all of these revolutions are counterclockwise. Right, so now let's talk about how we convert from radians to degrees. And then we'll also look at converting from degrees to radians. Whenever you're converting, if you're converting from radians to degrees, you take your radians and you multiply by 180 divided by pi. And that will give you degrees. When you're converting from degrees to radians, we start with degrees and we multiply by pi over 180, and that will give me my radians. The way I remember which one to multiply by, I remember in going from radians to degrees, we're trying to get the radians or the pi out of the answer, so we're dividing. And going from degrees to radians, we're putting the pi into the answer, so that pi is in the numerator. That's how I remember it. I don't know if that helps, but that's what I do to remember. So let's go through each one of these. Convert the following to radians. We have 120 degrees. I'm going to multiply by pi divided by 180, which gives me 120 pi over 180. And I can use my calculator to simplify that. 120 divided by 180. And I'm going to go ahead and do math, enter, enter. And I get 2/3. 2/3 pi. Now, if we were in the classroom, you would have to do this without a calculator. And the way I would reduce 120 divided by 180, they can both be divided by 10, so it very quickly becomes 12 over 18. Then I notice they can both be divided by 6, which gives me my 2/3. So it's really not that difficult to do without a calculator. 270 degrees, I multiply by pi over 180, and I'm left with 270 divided by 180 degrees pi. I'm going to do this one without a calculator. They can both be divided by 10, so I'm left with 27 over 18 pi. Then I notice they can both be divided by 9, and I get 3 on the top and 2 on the bottom. I divided both by 9, so I get 3/2 pi. 2/3 pi, 3/2 pi. Let's go to our next one. 135 times pi over 180. I'm left with 135 over 180 pi. Now this one's a little more difficult because they don't just both end in a 0 where I can divide by 10, but I do realize they can both be divided by 5. So I'm going to come over here off to the side, and 135 divided by 5. 5 goes into 13 twice, gives me 10, gives me, when I subtract I get 3 and I carry down the 5. 5 goes into 35 27 times. So I get 27 in the numerator. So I'm going to have my pi. Now I'm going to divide my 180 divided by 5. 5 goes into 18 3 times, which gives me 15. Carry down that 0. How many times does 5 go into 30? 6 times. When I get to this point, I realize they're both divisible by 9, and I get 3/4 pi. All right, for my last one here, letter D, 300 degrees times pi over 180. I get 300 divided by 180 pi. They're both divisible by 10, so I'm at 30 divided by 18 pi. I look at those and I realize they're both divisible by 6, so I get 5/3 pi. Now we're going to convert the following to degrees. So we're going to take the 2 pi divided by 3, and we're going to multiply it by 180 divided by pi. So the pi's cancel because I have a pi in the numerator and a pi in the denominator. They cancel. Now when you're multiplying without a calculator, it's always easier if you make the number smaller before you make it bigger. You make numbers smaller by dividing. You make them bigger by multiplying. So I realize that I can take 180 divided by 3, and that becomes 60. And I'm left with 2 times 60, which is 120 degrees. If I had first multiplied, I would have had 2 times 180, which is 360, and then had to divide 360 by 3. It's, for the most part, easier if you divide and then multiply. if you don't have a calculator. Next one, 7 pi over 4. We're going to convert to degrees, so we're multiplying by 180 over pi. Once again, the pi's cancel. And I have 180 divided by 4. I know that they're both even, so I can make that a 2. I can divide by 2, and I can make that a 90. And then I know that 90 divided by 2 is 45. And all I'm left having to do is 45 times 7. I'll do that off here to the side. 45 times 7. 5 times 7 is 35. Carry the 3. 7 times 4 is 28. And add 3, 29, 30, 31, 315. So I get 315 degrees. Letter C, I have pi over 2. Again, I multiply by 180 over pi. The pi's cancel, and 180 divided by 2, I know, is 90. My next one, letter D, I have 5.3. And since I'm converting to degrees, I multiply by 180 over pi. We're going to need a calculator for this one. And so I'll go to the calculator. So I've got 5.3 times 180. And then I'm going to divide that answer by pi. And I get around 303.67 degrees. 67 degrees. Okay. Now let's talk about the difference between magnitude and measure. When we talk about the magnitude of something, that's when we're using degrees or radians, for instance. The magnitude of, if I wanted to look at this angle here, let's say that this was a 75-degree angle, and I want to differentiate here. We say that the magnitude, the magnitude of the arc is 75 degrees. The measure of the arc is the length of the arc. So I'm going to get a highlighter here. So that right there that I have highlighted in orange, that would be the measure. That's going to be the measure. And then the magnitude of the arc is my degrees. So, because what can happen is I could draw a smaller circle, and I could draw, I am sketching, I get that. This is a 75-degree arc still. That's the magnitude. And now the measure of it is smaller. Even though it's still a 75-degree arc, it has a smaller measure because the circle's smaller. So this is measure. This is magnitude. So the angle is the magnitude, and the actual length is the measure.